In this example, we're asked to integrate cosecant squared over cotangent cubed of x dx. Well, since we have a quotient here, even though the cosecant and the cotangent can go together, because it's a quotient, the best thing to do is first change it to sine and cosine, treat it as a mixed integral, and then see where that gets us. So, cosecant, and I'll write this down to the side because some of you seem to be struggling with this part, is 1 over sine, and cotan is cosine over sine. So this is 1 over sine squared, 1 over sine squared of x. Now we're going to multiply that by 1 over cotangent cubed, which means really we want the reciprocal of that. So that's actually going to be multiplied by sine cubed x over cosine cubed x. So just to repeat that part, cotan is cosine over sine, so that's in the denominator. We're going to take the reciprocal so we can bring it up. So we flip it over. That cancels 3 of these with all of these, leaving us the integral of sine of x over cosine cubed of x dx. If you've done enough practice, you should now be able to see where this is going. We have cosine and sine. The cosine has the exponent. It's also in the denominator. So setting u equal to cosine just cosine, not cubed, cosine x, then du is negative sine x dx. We can substitute back here and hopefully see our answer. So sine x is negative du, so we're going to do negative the integral du. Cosine is u. We'll make it to the minus 3 because that's easier to look at. So there we substituted. The minus came from here. U minus 3 because we took it up top. Integrate then, we get negative u to the minus 2 over minus 2 plus c, which we can go ahead and substitute back, gives us 1 over 2 cosine squared of x plus c. Don't forget, when you're trying these, you can always take the derivative now and see if you can make this. It's going to take some work to do that though, because the derivative is only going to have sine and cosine in it. Then you'll need to use these properties again to make it look like that. On your tests or exams, don't try to check your answer by differentiation until you have everything finished. Otherwise, you could end up wasting a lot of your own time. So it's a good idea, it's good for practice, but on tests and exams, make sure you wait till after you do everything before you go back and check all your answers.